everyone. Today we're going to start talking about solving polynomial equations. And this is very similar to what we did with quadratic equations. Once we learned to factor them, then we moved on to solving. Just like with quadratics, our answers, whenever we solve polynomials, can be called roots, zeros, x-intercepts, or solutions. And this equals 0 is the change from factoring to solving. Before, we were just looking at polynomial expressions, but now that we have an equals 0, we can solve. Sometimes you'll see an f of x instead of a 0. We are going to set f of x equal to 0 in that case. As we solve, we are going to run across something called a repeated solution, and I'll abbreviate that with RS. When we have a repeated solution, it means that our factor and therefore our solution occurs more than one time, and it could either occur an even or an odd number of times. So even being that the same factor, we see it either 2 times or 4 times or 6 times, etc. Odd being 1, 3, 5, 7, etc. And something special happens with the graph when we have an even number of times that the solution is repeated. It's going to bounce off of the x-axis. It's going to come to the x-axis and then turn back and go back the way it came, either from above or below. If the degree is odd, it's just going to cross the x-axis and keep going. We'll see that a little later when we start graphing some polynomials. But first, let's go ahead and solve this one from factoring. And so in order to solve by factoring, of course, we first need to factor. And we're going to remember everything that we've learned in the last couple of lessons. The very first thing is, of course, to find our greatest common factor, which in this case is a 2x. Pulling out the GCF, I want to say what's left. And what is left is an x squared, a minus 6x, and a plus 9. And of course, we're equal to 0. So let's go ahead and make ourselves a note that we just did a greatest common factor. Now I notice that I have 3 terms left. If I have 3 terms, that means that I need to use quadratic form, and for quadratic form, we do an X box. There's probably a giveaway that I already have an X box set up over here. So let's go ahead and fill this in. I'm looking for 2 numbers that multiply to be 9. Remember, that's our A value times our C value. And then they add to be negative 6. 9 and negative 6. So I'm looking for 2 things that multiply to be 9, and they must both be negative if I'm going to add to be a negative 6 while multiplying to a positive number. So let's do our factors, negative 1 and 9, or negative 3 and negative 3. Well, the ones that actually solve my puzzle and add to be negative 6 is a negative 3 and negative 3. So I can go ahead and fill those in here. And then I can fill in my x box. Remember that the box part gets the x squared, my first term, and my last term, the 9. And then we fill in with our factors that we just found, negative 3 with an x and negative 3 with an x. Greatest common factor again, that is the theme for the Xbox method. Greatest common factor across each of the rows and down each column. So across this row, x squared and negative 3x is going to give me an x as a GCF. Negative 3x and 9, I'm going to have a negative 3. Remember, if the sign is negative on the box you're about to write next to, then that gets a negative. We have the same thing going down each row. We have an x and a minus 3. So after doing my x box, I still have this 2x. It's kind of coming along for the ride now because it's a monomial factor. It only has a single term, and remember, we can't do anything extra or anything else with those. But now I can write my newly factored x minus 3 and x minus 3, and I'm still equal to 0. Let's see if we're done factoring. We have a monomial term. We already talked about that. This is linear and this is linear because I just have a plain x with no exponent, or I could say the implied exponent of 1. So I'm done factoring, but I can simplify this a little bit. So let's do a simplify step. And the simplify step is, I notice that I have one of those repeated solutions. I have x minus 3 two different times. So instead of having it repeated this way, I'm going to go ahead and write it as x minus 3 squared. This is a little more simplified version. Let's go ahead now and do our next step, the thing that separates factoring from solving, and that is to actually solve. So in order to solve, we're going to use the zero product property just like we did with quadratics. That says that if we have two or more things that multiply together and the product is 0, that's why it's called zero product property, that each of those pieces can be set equal to 0. One or the other has to be 0. So let's say 2x equals 0 and x minus 3 equals 0. Now I just want to solve for x. I divide both sides by 2 on this one and get that x is equal to 0. I add 3 to both sides on this one, and I get that x is equal to 3. So these are my solutions, but there's one more note that I want to make because it's going to become important later in the lesson, and that is that this was an RS, a repeated solution, and it was repeated 2 times. So we can say that the exponent is even, and so that means that it's going to bounce on the x-axis. So if we graphed this, we would see that it was bouncing.